participants?
Okay, so we have now, you know, sir. So I don't think that I need to give more introduction. But for people who work on SKUAST, we have with us Dr. MAKROO. He is assistant professor in the Department of Food Technology. Sir has done BTech from IUST, MTech from Tezpur University, and then PhD also from Tezpur University. Sir has also been to University of Surrey. Sir, I consider him as my guru, to be very frank enough, because whenever I face any problem in any related to the food technology, so he would be the first person I contact him. So very much thankful to him that he agreed, because I know ये बहुत बिजी रहते हैं, वो मुझे पता है, क्योंकि इनका प्रोजेक्ट्स भी काफ़ी आए हैं, ये साथ भी बिजी रहते हैं, प्लस सैटरडे इनका अपना स्पोर्ट्स के लिए भी टाइम होता है, so for that matter also, but very much grateful to him that he agreed, sir, please.
Assalamu alaikum. Actually, sir has exaggerated a little bit. I consider him as my guru. In a lot of aspects, he has very good skills with respect to when it comes to technical writing. My English is pathetic because my school is from government school. So for that matter, I often contact him. So with respect to the today's workshop, I am here with a small discussion with you people, which is related to what we do in department, and especially with a group of 3 people, 3 faculties, and overall 28 people who are involved in some projects which are related to the theme of this workshop. I will discuss a little bit about what is circular economy and what approach we have applied in our lab scale to apply the circular economy approach with respect to the utilization of the food waste. So if we look at the scenario of FEO, you can see these are the data in which shows that the industry, what industry produce how much of the waste, and waste doesn't have a fixed definition. Let me tell you. Sometimes if it is waste, 30 years back something was waste, but now it is not even byproduct but the main product. I will come to that point. So waste, if it comes to a specific material or generated from the industry, it is not always, we can say it will remain always waste. The waste can be converted into byproduct. A byproduct can be converted into the main product. So these are the scenarios, like 30% of the cereals get waste from the beginning, from the farm to the industry, or even during the transportation. Similarly, the fruits and vegetables have the major percentage of losses, and we know the reason for that, because fruits and vegetables, most of them are perishable. Their shelf life is very short and they are delicate, like they are even susceptible to small forces as well. Like if there is a jerk during transportation, it may damage apples, right? Whereas there is no effect on the cereals. You can transport them in any conditions. So fruits and vegetables, that is one of the reasons. One is they are delicate. Second thing is they are very perishable. Similarly, 45% is roots and tubers. Same, because we can consider them in fruits and vegetables. They are also perishable, and perishability has a reason because their moisture content is very high, right? Dairy produce 20% of waste, seafoods have 30%, and meat produce around 20% of the waste. So before we discuss it, there are 2 terms, which is food loss and food waste. I hope you know what is loss and what is waste. So loss is which occurs until we develop the product. For example, if I am making ice cream from milk, right? From milking it from the cow until it reaches to the industry and we make the final product. If there is any loss during that, it is called the loss. So during transportation, during processing, during packaging, if there is any loss, if we lose some material, any part of the product, any part of the raw material, it is called as the loss. While as the waste is, once the product is developed, it is ready to eat, it is ready for the consumer. Beyond that, if it gets wasted, if it is not utilized, then we can say it is waste, right? So usually, sometimes we mix these terms, but if we come to the subject of food waste or circular economy, loss is when the product is not ready. If until that there is any loss, there is any damage, that is called as loss. Whereas once the product is ready, if beyond that, if it is ready to consume, if it is ready to serve, if there is any wastage, it is called as waste. For example, if I had my lunch, if I left over some rice on my plate and I throw it in the dustbin, it is loss. And when I mill the same rice in the industry, if there is it is called as a loss, right? So I believe loss has a control, while as wastage should come from the conscience, right? Wastage can be prevented by conscience. So it is major part of the wastage is because of the consumer approach. So I will tell you one example. Like here, if we go to restaurant, we get food based on the servings. We ask for one plate rice, one plate some vegetable. But if you go to Latin America, there is a huge problem of losses in restaurants. There they have applied a different approach. There is a buffet system. Whatever you take, you have to weigh it. After weighing, they will charge. So for that matter, if you buy chicken, if you buy rice, if you buy carrot on the same plate, the price of the chicken, the rate of the chicken, rate of the rice and rate of the carrot is same. But there is a advantage is that I will take that much whatever I need. जितना भी मुझे चाहिए, अगर मैं एक टुकड़ा भी गाजर का लूँगा, मैं कितना भी ले सकता हूँ, right? But here if you order, you have to at least order one plate of salad, right? Not necessarily one person can eat it. So most of it sometimes it gets wasted, right? And there is everything kept in buffet system. That is how they approach to prevent the losses especially in the restaurants. Because Latin America is something, their mentality is somehow like ours. People from subcontinent. हम खरीदते हैं, हम परवाह नहीं करते कि अरे मैंने खरीदा, मैं खाऊंगा, तो हमें बुरा नहीं लगता. Right? We don't feel bad when we throw something if we have paid for it. We take it for granted. While as people in developed countries, they feel bad. Even if they have paid for it, they don't want to throw it. Right? In the same way, the kitchen waste in UK, they use the kitchen waste to generate electricity. And 16% of the electricity is generated from the kitchen waste. Now you can see, जो हम चीज़ फेंकते हैं, they use it to generate the electricity. And UK is also a cold place, they need lot of electricity. So similar to our place, Kashmir. So they can use that kitchen waste to generate the electricity. So that is how, these are some examples how different organizations or countries or different area have different approach towards the prevention of the waste, right? Loss is at the industry. Loss has some different approach. I am talking about the wastage. Waste is not always waste. You know the story of cheese industry? When in Europe people used to make cheese in 1970s and 80s. Their main product was cheese. Can anybody tell what cheese is this?
Swiss cheese.
Why is it Swiss?
Because it has holes.
What are those holes called? One cartoon, he mostly consumes it, right? Mickey Mouse. Right? Okay, Tom and Jerry. So this is Swiss cheese, and these eyes, which you said is hole, they are called as eyes. There is science behind it. I suggest you to go through it because it's very interesting. Because these get developed because of the generation of the carbon dioxide. There are two microbes involved in the development of the cheese. When it generates carbon dioxide, and that carbon dioxide gets entrapped in the cheese, and that is how this structure gets made. And this is the, you can say, one of the indicators to show the good quality, or you can say that this is Swiss cheese. So that is something out of the box. But in 90s, 80s or 70s, cheese was the main product, right? Whatever the waste they get after, making curd, right? Because it is fermented cheese. It's not the cheese which we make, which we call cheese, which actually is not cheese. That's coagulated milk, right? Even whatever the whey, the serum part, they used to throw it. It was a problem there. What they used to do is they used to throw it in land for agriculture. Then came the environmental people. No, it is creating mess in our environment. You cannot throw, it into the fields, right? Because it changed the pH of the soil, it causes the soil pollution, and it may lead to different issues with respect to the agriculture or the soil quality. But then they came up with a idea. So this whey, this serum part, which we call whey, contains a lot of things. It contains sugar, major sugar part. Which is the major sugar in milk? Lactose. Which is the non-coagulating protein in milk? Whey. Caseins get coagulated when we coagulate them, but it contains a lot of whey. Although cheese also contains some whey, but the liquid or the serum part is mostly composed of water. It contains some sugar, and then it contains some protein also, and major proteins are whey proteins. So what they did is they extracted whey from it. You can see this diagram, you can see to any pharmacy nowadays, they sell the बड़े बड़े डिब्बे बेचते हैं. जिम जो जाते हैं वो उनके बड़े डिमांड है इस चीज की. And now lot of cheese industries are established to develop whey. Their main product is whey now, and their byproduct is cheese. They don't make cheese to make cheese. They make cheese to make whey. Right? So it is basically they use this step. Do we have this? So this step they use as a separation method. उनका और कोई इंटेंशन नहीं है. उनका मेजर प्रोडक्ट ये है. Lot of cheese industries. So by the way, you know what is the difference between recycle, reuse, upcycle, downcycle? What is recycle? I throw a bottle, we will reuse it for the same purpose. What is upcycle? What is upcycle? This is upcycling. It was a waste, major product was cheese, and we use this way for at the higher rates or for the superior product, right? So we upcycled, which was earlier waste. The dairy industry has upcycled it. Downcycle is when we use it for when we produce something and we use it for some lower quality product. So these are also the terms related to the circular economy. This is also an approach for the circular economy. So food waste can be generated at any step of its production, even at the time of cultivation or harvesting. It can happen at processing stage when we process the material. Right? Polishing of rice is processing. We polish the rice. We mill the rice. That is a processing. Squeezing juice out of fruits is a processing method. Or when we heat a material to during canning, we can say, or thermal processing. That is also a processing. So at the processing stage also there is a lot of losses or which used to be wastage, but now it is not waste. Retail. If something remains unsold, it gets wasted, right? Or if sometimes there is damage in the product, we don't buy it, it gets wasted. Like if we go to buy fruits or in supermarket, if we find something which is damaged, we will not take it. we will take which seems good to us, right? So even at the retail there is wastage. At consumption, as I said, it is the where the wastage occurs. We buy it, it is edible, but we don't consume it for money reasons. Sometimes it remains there, right? Sometimes we open it, we couldn't consume the entire portion of it, so we throw it, right? So there are different this, but can we apply some scientific approach to utilize what has wasted, what has generated from the industry? So we can make the animal feed. If it is not edible to human beings, we can convert the wastage into this animal feed. It has application to make at least compost. As I said, we can use to make it for biofuel, right? What is biofuel? In Sao Paulo is a city in Brazil. There all the buses run on biofuel. 60% of the cars run on biofuel. And the source of biofuel, what is the source of biofuel? Which waste? Which is the major material they use to generate this biofuel? What is bagasse? Bagasse. When we squeeze sugar canes, the leftover is bagasse. They use sugar. Sometimes they use whole sugar cane, but they use it to make the ethanol, and their cars run on ethanol. I was once there, and we took a car from airport. There were some friends of mine. They are from northern Latin America. So we stopped somewhere on a fuel station, and they asked that person. So he asked the driver who was the friend who was driving the car. He asked the filling guy, ethanol. So I was thinking that maybe they call normal alcohol, the alcohol they drink, ethanol. So he wants to buy it. So I asked him that don't consume it while you are driving. Whenever we reach the destination, then you can consume it. He said, no, I don't need it. I want to fill the car with ethanol. At that time, first time I use a car running on the ethanol. So there is an option, like when we go to fill to the fill station, there are options of diesel or petrol. But there is diesel, petrol and ethanol, right? And that ethanol they produce from the bagasse or the sugarcane waste, or sometimes they use sugarcane also because they have to ferment it. We know the fermentation process, how alcohol gets produced. It's a two-step process. Once sugar gets converted into acid, then acid gets converted into alcohol. That how fermentation, distillation. Distillation is the last step when we need the spirits. But fermentation, it is the fermentation process. So they ferment the sugarcane waste to the alcohol, and they use alcohol as the biofuel. As I said that all the buses run on the biofuel or the ethanol or the fuel generated from the food waste or the agricultural waste. So why to utilize this food waste or the food byproducts? One is because population is increasing, sources are limited, so we can reduce the source. The sources can be reduced. Second is we can feed the hungry people. For example, if I have leftover something which I feel my status cannot consume it, but there are a lot of mouths which eat it, right? Like what we live in while traveling in train, lot of people come and they eat it, right? For them it is edible. For me it is a waste. So if we apply some approach to convert it into the feed, we can eat. And this thing we can apply in Vazwan. Lot of leftover is there, right? Once I have a friend here, I told him, I was there for a gathering. I had lunch, dinner or lunch, I don't know whether to call it lunch because they serve it at 5 p.m. I don't know whether it's lunch or dinner. So it was lunch for me. So there was a lot of leftover. I asked him what you will do. He is from Srinagar. He said, we will throw it on the road. I said, no, it's not the right way. He said, no, what will dogs eat? What will birds eat? It is food for them, nothing is wasted. So that is one approach. To some extent, he made sense, right? But it's not the way to feed them. We can feed them from other mechanism because it leads to many other things which are not good, right? Sometimes it leads to diseases. Sometimes a lot of dogs gather in the society, in a locality, and they start attacking people, especially kids, right? So we can feed animal by approaching some scientific approach, right? We can make a low-cost pedigree. Industrial uses, we can use it for industry. I had a friend who is from Thailand. She developed a face pack from banana peel, and she is marketing it. And she said it has better results than any other face pack available in the market. Right? So she is using the peel of the banana. She is removing the upper layer, which is the yellow color. The rest of the inside is starch. So she extracted that starch and added it with some other things, which is her. Yes, scraped. And she said I got better results, and she is selling. So we can use it for industrial applications, and it's not only we can use the waste in food industry only. We can use it in any other industry like pharmacy, like in cosmetics, right? Sometimes in bioplastic, packaging industry, and many more. Composting, if we can't do anything, at least we can compost it, make manure from it. And if even that is not possible, have you been to Delhi? Have you traveled Delhi by road, by bus or by car? Before entering Delhi, Azadpur area, transport nagar, जहाँ पर वो बहुत सारी चील कौवे होते हैं, वो पहाड़ है, लेकिन वो पहाड़ नहीं था, वो कूड़ा है. So they filled it, right? And now they sprinkle water on it, and it just gets composed with time, and they add some seeds while filling those. So वहाँ से पौधे निकल रहे हैं. It looks green, but actually it's not the right good idea. If you go there, it is unbearable. और जो नया बन रहा होता है वहाँ पर वो चील कौवे होते हैं. So that is the last option what we can do. We can do the land fillings, which even in Kashmir we have started, but that is not the right way, I believe, at least for this place. We cannot bear this kind of disposal, especially the disposal of plastic, because nothing will happen with it, and we don't have that space that we need, use this space for filling the plastics or land filling it with the waste, which gets deteriorated in thousands of years. So these are some approaches which we can apply. The last option remaining with us is the land filling. Now I will come to my part, or our part rather. Because I am not an entrepreneur, I am not a businessman. I do small experiments in lab. We do small experiments in lab. So we have applied some attempts to apply the circular economy approach for utilization of the food waste or byproducts. Some of people are involved in some of such tasks. So first, I will discuss about the major fruit which we produce in the valley is apple. If you know, once the apple is ripe or mature, it's not a problem. We can consume it. But there's a huge loss of apples at the stage of when it is immature. छोटे गिरते हैं वो. If you look at this diagram, this shows the growth of the apple. First the bud comes, then you can see the dates also. These are the pictures at what date we have taken. So this actually shows how a fruit on apple tree grows. It starts from a flower early in spring, then it becomes a full bloom. I don't know, there are different, green tip, pink tip. There are some terms for budding. Even these are the stages of growth. So then around after 1 month, there was a little development of the fruit, and after that it increases its size or weight, you can say. So here you can say that around after around 2.5 months, the weight of the fruit was around 110 grams, right? And this is the time after flowering, after 2.5 months, it is at the mid of its growth. It has to reach to the mature stage and then to the ripe stage. But because of lot of reasons, the fruit starts falling. If you have apple tree at home, even you can witness it. There you will find lot of apples, green apples at even immature stage. They start falling, and their fall increases with the time, which is sometimes called as June drop or early drop, because it starts in June, that's why it's called a June drop. So nearly 20 to 50% of the crop falls during this. So this thing has taken our attraction. We thought that it is a bioresource. And another problem with this is, for example, if we have vegetables at home, if it gets wasted, at least what we can do is we can give it to the animals. If somebody has cow, if someone has cattle at home. But the problem with this thing is, even cow doesn't like it. You know why? Because it's very sour. Its pH is very low. ये बहुत खट्टा होता है. Normally हम भी बोलते हैं ना कि ये पका नहीं है, ये क्योंकि ये खट्टा है. जब पक जाता है फल तो वो मीठा हो जाता है. There is another science involved, because starch gets broken into sugars. These sugars neutralize the acid present in it. But the problem with this is, even we cannot use it for cattle. But the only option with the farmers is they take it and dump it. Even dumping is problem. I will tell you really, one of my students worked on it. When I asked him to get some samples from your hometown, he is from Shopian sir. So when I told him to get samples of different varieties, we want to analyze it and we will work on it. So he got 5-8 kgs. So he got it from some neighbor's orchard. So once he got it, he told me that, sir, when I was collecting, they asked me, what you will do with it? Even the farmers were excited. ये आप क्या करेंगे? इसका क्या करेगा ये? ये तो waste है. इसको क्या करना है इसको? And they know that he is studying somewhere in university. So they were very curious. What you are going to do with it? He said, no, we are doing some experiment on it. So if we succeed in future, even you will get money for this. So they were very excited. They told him, okay, what will be the price? So he said, we haven't reached to that level yet. I will tell you what will be the minimum price. They said, even if you give us 1 rupee per kg, we will sell it. Just take it from here, because it's a problem for them. So this problem fetched our interest. So we considered it as a bioresource because we know the development of the fruit. It develops from flower, then it becomes, it has lot of polymeric compounds in it. For example, pectin, which is, which keeps the cell intact, or cell wall. Cell wall has 2 major, components in it. One is the pectin, another is the cellulose, right? And hemicellulose, lignin, they are also there. And you know why when we bite an apple which is fresh or juicy, it makes a noise of crunch. Why is it? It's because of what? Because of what? And if it ages, मतलब तो सोच बना, उसमें वो आवाज नहीं आती. Why? There is a parenchyma. सुना है? So it is because of the parenchyma. When it breaks, it makes a popping noise. So even that is one criteria of quality of the apple. When we get the apples from America, जैसे चुना California चुन, देखा है वो बहुत crimson red color का होता है. When it reach here in off season, the major attribute of the quality is that it has that bite in it. The taste is okay. Even taste हमारे सेब का भी होता है, लेकिन उसमें जो bite होता है ना, अभी आप जो golden delicious या चमुरा सेब खाते हैं ना, वो थोड़ा dry हो जाता है, उसकी skin थोड़ी वो sometimes, right? It shrinks, right? And we don't usually like it. उसमें वो bite नहीं है. But if you take that apple, it has the bite. That is because of their storage, their transportation, and their quality standards. So as I said that, it is also the quality factor even in the fruits. So these are the components, polymeric components, which are responsible for the bite or the noise or the popping sound when we bite it. So this was a problem taken in our lab. So we had many approaches to use this. I will discuss a couple of the approaches. So first approach is that, can we process this? Can we process it to extract starch from it? Because it contains mostly water and some major components, and starch is one of these components. So we tried to apply some established method to extract the starch. Is it a signal that my time is up? So we filtered it, we centrifuge and we dried, and we got a powder. And it was not the pure starch. We cannot say it is extra pure, but we got the starch in its impure form. We can say the purity was somewhere there. So starch, why we targeted starch? Because it is the most abundant polysaccharides present in plants after cellulose. Because cellulose is in some non-edible part also, like the trunk of this tree is composed of cellulose, leaves have cellulose, branch have cellulose. But this is this, and starch has many applications. From getting up in Western countries, they use starch in the toilet paper. And when they sleep, if they need to take a pill or the capsule, even that is composed of starch, paracetamol. So from starting the day and winding of the day or taking off from the day, we use starch at many. We eat starch. We use it when we write, right? We use it as a base in the formulation of pharmacy. जो आप face pack लगाते, its major component is, earlier it used to be multani mitti, but they cannot use multani mitti now. But they use starch bases, right? Filters, just air conditions के गाड़ियों के filter होते हैं. It has the paper in it, and in paper the major component is starch. So starch has a lot of applications. So it has application based on its properties. For example, if it is gelling, then we can use it as a gelling agent, right? We sometimes use it as a thickening agent, right? For example, in ketchup or sauces or नॉर जो आप पीते हैं ना, soup, उसमें जो thickness आती है is because of starch, right? Even in many restaurants, they add starch powder to make the gravy thick, right? इसलिए लोग बोलते हैं पंजाब में जाके फिर मोटे हो जाते हैं, पेट निकल जाता है, because वो चावल भी starch ही खा रहे होते हैं, उसको सब्जी समझते हैं वो भी starch होता है, the colored starch you can say. And sometimes we use it as a stabilizing agent. As I said, we can also use the starch as the in pharmacy as a base material for the in drug delivery. Paracetamol में 5 mg होता है, sorry 500 mg होता है paracetamol. बाकी क्या होता है? So इसमें 8 ग्राम आता है, 2 ग्राम होता है. Rest is the starch. So with the time, starch has got some more applications. We use it in generation of the biofuel. So this apple we use, we got around 29% of the starch on dry dishes. So the parameters of the apple were that it contains around 90% of the moisture. pH was 3.86, as I said. बहुत sour होता है, इसको गाय भी नहीं खाती है. So these are the preliminary analysis of the raw material, and the starch which we obtained was high amylose starch. And when I say high amylose starch, this property will decide its application. You know what is the difference between low amylose and high amylose rice? Amylose, I said. I don't have knowledge about glycemic index, but it's not necessary. It doesn't have a direct relation. Maybe it has, but if I say that the rice which we eat normally it has no amylose, it's waxy, right? But when we make special, recipes like biryani, the starch is of high amylose. This rice contains high amylose starch. So these are the tasting properties and the rheology of the starch which we obtained. So we got a good peak in it. Even based on its peak viscosity, also we can, discuss. We can make it use for something where this kind of starch is used, and its flow behavior was non-Newtonian, right? So this non-Newtonian behavior can make it used for using in tomato ketchup. You know what's the difference between tomato ketchup and tomato sauce? Flow. What is flow? What is the difference between sauce and ketchup?
Thick and thin.
Thick and thin. Okay, tell me, is sauce thick or honey is thick? But if you pour honey, it will drop. But if you make the bottle of ketchup, it won't come out. It need a jerk. बोतल आते हैं ना किसान उसको ऐसे ऐसे करना पड़ता है जब आपको मैगी के साथ खाना हो पैटी के साथ खाना हो but if you put a spoon in the ketchup it is very easy to move it inside but if you use the same spoon in honey it is very difficult so consistency has nothing to do with its flow behavior it can be honey is non-Newtonian flow you don't need any force you just turn it upside down it will start flowing that is a separate story but this behavior of this starch it can be used in the ketchup industry या spread जो bread पे spread fruit based spread बनाते हैं jam jelly को छोड़ के there are spread has some different other definition so this starch can be used can be incorporated in the tomato based or the fruit based products and then we can launch it in the market with some different name we can say that it has better starch in it it doesn't have the potato starch because potato starch may have lot of issues with it. It may not be suitable for the diabetic people. But maybe this starch is suitable for them, then we can use it. Or maybe we can use it in the formulation of baby or infant formula. So this is another characteristics in which we measure the hardness once we cook the rice, cook the starch, and after that we make a gel of it. We keep it for 24 hours and then we check how much force it will retain and how much is the capacity to return back जिसको हम फिजिक्स में स्प्रिंजीनेस बोलते हैं स्प्रिंजीनेस कि वो वापस कितना आता है जैसे आप when we buy a loaf of bread हम उसको कैसे मेजर करते हैं हम उसको टैप प्रेस करते हैं फिर वेट करते हैं अगर वापस आई तो ये अच्छी है अगर वो वहीं पे रहेगी तो वो अच्छी नहीं है या नॉट गैसेस से बनी तो दैट इज रेटोरेटेड राइट वो दबेगी ही तो पहले सॉफ्ट देखते हैं पहला क्राइटेरिया कि सॉफ्टनेस होनी चाहिए second criteria once it has we dipped it to a certain depth when we remove the force it should come back that is called as springiness and that parameter is in this starch and this it has a springiness almost 0.99 that is close to 1 it retain its shape back this point will decide its application in pharmacy for making hydrogels hydrogels की applications बहुत सारी होती है आजकल hydrogels has the application in drug delivery, right? Hydrogels has the application in, making soothing effect. जो मरहम पट्टी करते हैं ना, उसके अंदर कुछ हाइड्रोजेल लगाते हैं. It stops oozing, it stops, it relieves from the pain. It sometimes stops the inflammation. So those kind of applications we can use this starch for. So this was the morphology and its morphology was, it is granule size of the starch, granule size was of different, but the diameter was in the range of 7 to 13 micrometer, but it falls in the lower granule size. There are a lot of sources in which the granule size is larger. So second approach was, once we are done with starch, we found that okay, starch is fine, we can get starch. So can we process this material to extract the pectin? And I said yes, we got the pectin as well from it. And we know the application of pectin. pectin is edible. हम खाते हैं pectin को. We add it in lot of formulations, and pectin has a functional role in lot of products like jam jelly नहीं बनेगा without pectin. तो pectin कभी-कभी गुस्सा हो जाता तो नहीं बनता. So it is very delicate, right? You have to take care of the pH of the formulation. You have to take care of the total soluble solids, TSS जिसको बोलते हैं आप. तो what we did, we approached a conventional method and tried to see how much pectin is it in it and can we extract it. So pectin is an heterogeneous complex polysaccharide. We know that उसकी जो base होती है क्या होती है? Polygalactonic acid. So it has very lot of applications and it has very health benefits as well, and especially with the bowel movement, right? It helps in the movement of the bowel, and so it is defined as a dietary fiber. It has applications in jams, jellies, pharmaceuticals, nutraceuticals as well, and in bioplastic. We can use it as a setting agent. अगर हमको कोई biofilm बनानी है, we can add pectin it and check whether it will give it the desired characteristics or not. So mostly pectin is made up of galactorinic acid, and galactorinic acid has nearly 65%. जब 65% होता है तो we can say that it is pectin. So other polysaccharides are around 35% present in the pectin. This is the general definition. So these are the visuals that one pectin is the pectin which we got from the apple waste or immature apples. Second is the commercial apple, we got it from high media and we try to compare it. The pectin we got was slightly yellowish in color, right? And the pectin which is produced is very pure. Its color is near to white or creamish white. So moisture was similar to each other. Water activity was same. It was little bit higher in our case because we couldn't dry it to a very higher level. Probably because of the constraints of not having that sophisticated dryers which they use in industry. So ash was again less in our this mineral content. Galactorinic acid, as I said that in our it was 68%, so it fits the definition of FDA that it is pectin because it is more than 65%. If it would have been less than 65%, then we cannot say it is pectin. So in commercial it was 72%. Degree of esterification, you can say it is similar. Again, if we say that it is similar to the commercial pectin, and degree of esterification has a role in jelly. So it can compete with the commercial pectin, which we derived from the apple. Methoxy content was very high in ours. Equivalent weight was little less what we got, and these differences could be because of impurity in our this, or some of the loopholes while extracting the pectin, or some of the degradation which occurred in extracting the pectin. Maybe sometimes we couldn't control the temperature properly. So overall, it was, we can say that it has the possibility is there to extract pectin from what the waste which we usually throw. The last signal. So these were the spectral analysis. You can see the bonding was almost similar, but in this black is for the commercial pectin. Somehow there were some conformational differences, or the bonding was not similar to each other. So that is again, as I said, that there will be some degradation in the structure of the pectin, or there could be the impurities present in our sample as compared to the commercial pectin. So morphology also suggested that somehow it is similar, but some impurities were also determined there as well. So this shows the composition of carbon, oxygen and nitrogen. So again it shows that similar kind of areas where uniformity in the oxygen and carbon in the commercial as well as the apple pectin which we derived in our lab. Crystallinity was like commercial pectin was more crystalline, which we compared it with the results, but the extracted pectin has little crystallinity as compared to the commercial pectin, but that could be improved. That could be make comparable with the commercial pectin. Thermal analysis again showed some differences, but stability was same. Thermal stability in both the cases was same. So both of them were stable in the range of around 150 and 180 degrees Celsius. So it was similar in both the cases. Rheology, again we used two different concentrations and then we checked the detailed rheology of it, and it showed the power law. On contrary to the stars, it showed the Newtonian fluid or the power law model. So we can use it for the products where we don't need to give the force, or it can gel a material but that gel will flow on its own. So we observed that at 9% it was getting extremely hard. So up to 6% we can use this pectin in the food formulations. Now this was when we targeted the component. I forgot to say that we are working on another component in the same material. We have got the results. I have some pictures also, but which I don't want to show because they are very crude. We recovered cellulose after removing starch from it, after removing pectin from it. We collected cellulose also, and we know the properties of cellulose and its application. And we got around 26% of cellulose from depectinated apple waste or immature apple waste, which is again very huge in terms of if it comes to industrial application. So we are throwing only whatever juice is coming out of it, that we haven't analyzed yet. But recently I was looking into the literature that even people are making vinegar from out of it. So even that is not the waste. War juice, जो कच्चे fruit ये होते ना, grapes, they are very sour. In Turkey they make vinegar out of it because acid is already there, so they ferment it and to make the vinegar out of it. So can we apply that approach? So in that case it becomes a whole circular economy. We extract the entire solids from it, starch, pectin, cellulose. We were throwing juice out of it, but now we will not even throw that. We will use that liquid portion also. We will ferment it and make some product which is again that we haven't explored yet. We don't know what we will get, but that is in the pipeline. We will try to analyze that also. As of now, when we discussed that, we took a product and we extracted the components using the conventional method and tried to see what are the components present in it. But sometimes there are different ways to extract the material, different ways to recover the material. So we applied different approach to extract very essential industrial component that is called oil. Oil has many applications. We eat oil. Oil we use in lubrications. Oil we use even in road making, right? It has lot of applications. So fruits and vegetables contain enough amount of oil, right? So, and these oils are rich in bioactive compounds. They have antimicrobial effect. They contain antioxidants, right? इसलिए बोलते हैं ना कि राइस ब्रान ऑयल क्यों खाना चाहिए? It has oryzanol है. What is it? Main fish oil में क्या होता है? Omega 3 fatty acids, right? तो उनकी एक प्रॉपर्टी है, वो आप मेडिकल या प्योर केमिस्ट्री वालों से पूछ लेंगे. So lot of oils have very huge market value. Again I said राइस ब्रान की एप्लीकेशन क्या थी? गाय खाती थी इसको, ये फेंक देते ना, गाय खाती थी, या लोग इससे बर्तन मांज देते, यही काम था इसका. लेकिन यू कैन सी नाउ राइस ब्रान ऑयल इज more expensive than the normal oil. मस्टर्ड ऑयल से भी बहुत महंगा होता है. So that is again an approach of circular economy or waste utilization. राइस ब्रांड से ऑयल निकाला, उसके बाद जो आपको उसको करना है, गाय को खिलाओ, किसको खिलाना है. इट इज रिच इन phenolic compounds and many more properties these oils have which are present in the fruits and vegetables. But the aim of this work was that can we see the effect of different approach to the recovery. हम एक्सट्रैक्ट करेंगे, एक नॉर्मल मेथड से करेंगे, दूसरा कोई और मेथड लगाएंगे, तीसरा कोई तो और मेथड लगाएंगे, एंड देन वी विल चेक व्हाट इज द recovery. How does the approach affect the recovery? How does the approach affect its properties? Because the conventional methods of extraction are time consuming, there is little recovery, they need lot of solvents, they are very complex, energy consuming. So there is need of for development of novel processes or some different approach or some innovative approach to extract the oil. And this approach can be applied for the normal extraction, जो main product extraction होता है, जो main oil seeds होता है. But what we did is we applied the different approach on the waste. As I said that we are a couple of people who are working on the waste. So we took a material which is usually people don't work on it. It is used as a fuel in industry. The industry is the chili industry. We make chili powder from chilies, right? The waste which comes out is seed mostly, the inner portion of the chili. And we sometimes use it as flakes. But these are not, all the chilies do not contain the seeds which we can use for flakes. जो आप पिज्जा के ऊपर डालते हैं ना सीजनिंग, वो नॉर्मल हर कोई चिली सीड नहीं होता. There are some specific chilies जिनके flakes बनते हैं, उनको काटते हैं और कुछ seeds डालते हैं. But all the seeds cannot be used as in the seasonings. So we analyze the chili seeds, and before doing this work, we consulted the chili processing industry जो chili powder बनाते हैं या chili का paste बनाते हैं. They said that when we process the chili paste, हमको उसको thermally process करते हैं. So to generate steam, we burn it, right? जब उन्होंने बोला we burn it, तो उन्होंने बोला ये बहुत अच्छे से जलता है. तो oil is fuel. That means it contains lot of oil, right? So our approach was to extract the oil from chili seeds using different methods. Although we worked on fibrose, we worked on protein also. So we have extracted most of the components from it, but the discussion here is about oil only. So different approach we applied where we used the sonication, which has the principle of cavitation or bubbling forces, microwaves, the heating, it's again the heating method, but we use the microwave radiations to heat the material. Sometimes it heats uniformly, but there are a lot of limitations with microwave, which I am not going to discuss right now. But with respect to the heating, it has many limitations and many advantages. Obviously, we applied the electric field to increase the temperature. So when we applied the electric field, we used different electric fields and we checked the recovery. So on the left you can see the yield, it was changing, and in some cases while with the time it increased initially, in some cases it decreased. For example, at the highest electric field, that is 3.5 volt per centimeter, it shows an increase and then it depth. The triangle you can see, the maximum recovery was in that case, but when we reached around 6 minutes, the maximum yield was obtained, that is around in between 16 and 70% of oil. But if we increase further, when we increase further time, we reached up to 8 minutes, the recovery was less. So then we observed the reason. What could be the reason for this? It is because during applying the electric field in the extraction process, it opens the cells, which is called as electroporation. But sometimes if we further increase, if we expose it for a lot of time, the proteins present in the plant matrix get denatured, and this denatured protein closes the whatever the openings it has created. So again it makes the extraction difficult. So our aim to apply the electric field was to recover maximum, and we observed that we have to stop somewhere in terms of the time or in terms of the intensity of the electric field. So this is the phenolics. Even phenolics got damaged. We got them maximum around at 6 minutes in case of 2 volt per centimeter. So it was not a linear relation with it. It increased and then it decreased. So polyphenols also got affected with the level of the electric field as well as the time duration of the applied electric field. So as I said that it has the microbial inhibition properties. So we checked it. You know how we check the antimicrobial activity of any material? Has anybody done it? No, that is what we did. What we do in microbial analysis is I took a sample. I will calculate how many bacteria it contains. That is microbial analysis. I have to check antimicrobial activity. ये कितनों को मार रहा है? How we will do it? What I am saying, you are exactly saying in some private English school. What I said is in government English school. आप मेरी बात को repeat कर रहे हैं. I am saying how we can do it. आपने थोड़ा sophisticated वे में कहा, inhibition use किया, और थोड़ा आपका accent थोड़ा British जैसा है. मेरा तो कश्मीरी है. बोलो आप. How can we check it? See, what we do is we make a film or the plate full of bacteria or any specific bacteria, right? And then we dip the disc-like structure in the material of which we have to measure the antimicrobial effect. And we place it on that disc and keep it for some time. This you can see, A, B, C, D, right? These are the discs which contain some component. तो इस डिस्क ने आपने जैसे A है उसके आसपास देखो ये white portion है. That means it has killed microbes up to that level. If you see the B, उसका जो white portion है वो थोड़ा कम है A से. If you go to D, it has a higher white portion, right? तो इसने उनको बहुत पीछे खदेड़ दिया. तो यहाँ तक इसकी माइक्रोबियल ये. Then is this C? It has no effect. This is how we measure it is the basic or simplest method to check the antimicrobial activity. So you can see here we took a fruit sample which was spoiled and we washed it. Then we grow those microbes on a plate. As I said, that base bacterial growth होती है इसके. Then we check the inhibition zone. We measure the diameter. किसका ज़्यादा? जैसे C का है, no, it is 0. क्योंकि उस diameter से उसका माइनस करना पड़ेगा. या radius ले सकते हैं. So here in conventional you can see the maximum diameter was obtained, that is 20 mm. When we use the oil which was extracted by ohmic heating at 2 volt, it has 15. And we increase the level of electric field, it has 30. So what we observed that electric field affects the antimicrobial property of the oil, which is a negative. Although we got the good yield, but बहुत ज़्यादा oil मिला लेकिन उसमें antimicrobial property नहीं थी. If I use this oil as antimicrobial agent, जैसे I am adding it in toothpaste, रामदेव बनाते हैं ना कोई तेल, उसमें तुलसी का तेल डालते हैं, किसी चीज़ का तेल डालेंगे, बोलेंगे इससे, but it will not work by extracting it with the electric field. So these are the different, microwave level powers: 300, 550, 720, and 900 watt. And on the other side, it is the amplitude of the ultrasound which we apply. So it has how it has affected the yield. These are some results which we observed that if you see here in this, we got the good results, but the results were in a smaller range. It started from 9.8% to 10.5%, right? तो 125 सेकंड में ही हमने 10.5% यील्ड आया हमें, लेकिन उसके बाद वो कम होता गया. लेकिन ओवरऑल भी अगर देखा जाए तो उस रेंज बहुत कम थी. On contrary, if you look at this plot, it starts from 10.5 and it reaches to 14. So the range was huge. So this shows the effect of the microwave power, right? When we conduct the experiments with microwave, we conduct it taking into consideration a lot of things. Maybe some of you are working in PhD, right? Sometimes we make small mistakes. But in case of microwave, the sample size should be same. The bowl which you are using, you should not change it. It should be the same. The volume of the material should be same, and the area which is exposed should be same. Then only you can correlate the results. Otherwise, if the area is less, even if the volume is same, the exposed area is less, you won't get the good results. You cannot compare them, because microwaves, it depends upon the exposure. It depends upon what is the volume. It depends on the level of the power which you have used, and it also depends on how much time you have kept your sample in the you have exposed your sample in the microwaves. On the other side, we check the effect of the amplitude of the ultrasonication on this, and we got results up to 14% using the ultrasound. Ultrasound is a cold method, while as microwave is a hot method. So these are some observations which we found, that the starch derived from the mature apple has functional characteristics comparable with the commercial starch. So it can be used in food and related industries. The pectin which we obtained was containing electronics of 65%, which satisfies the criteria of the FDA. The resemblance of extracted and the commercial pectin reflected that we can replace the commercial pectin with the apple pectin, provided we make it little more pure, because I agree that the pectin we extracted was not pure. So we can further apply, as I said, that we can process, we can use the juice which is coming out of the apples, which will completely satisfy the circular economy approach. Otherwise, in circular economy we don't throw anything. Whatever is coming out we use, but we use that in case of the chili seeds. We extract the protein, then we extract the fiber, we remove the protein from the rest of this, and whatever left was the oil. So in oil we check the recovery of oil using different approach. So yield was dependent upon the approach used. Phenolics and the antimicrobial property was affected with the approach, but the flow of the oil was same in all the cases. So these small experiments are sponsored by different funding agencies. So I am thankful to all these agencies. This picture is very old. Our group is very big now, and a couple of people have left from this group. They are busy. They are engaged in some other things now. But this group is almost 3 or 4 times now. So this is an old picture of our group. And we are working on a lot of more things, because time was less, and we are working on some other interesting things like the waste produced by doodh wala while making paneer. One lady here is working on it. She has extracted good amount of lactose from it. So we are trying to use that lactose in baby formulations. So can we replace whatever lactose is there with this, so that we can use that waste or the byproduct produced. Another study is, which is very confidential, we are working with the walnut hulls. So we have got very good results. So we will compile that study and work on it. Thank you so much, and if you have anything to ask, you can ask. I said I am not an entrepreneur, so I cannot give a touch to the entrepreneurship, but you can apply your mind and you can make an entrepreneurship out of it.
Students, any query?
They don't have usually, with respect to me.
But
they have queries out of department. When they go out, they have made lot of WhatsApp groups which are against me. So they do lot of preaching about me. But you are always welcome to listen to my shouts and screams. But those students who left, they are still in my contact. and from that I assume that I have done something. We have a good relation. Otherwise, if I had bad relation, they would never contact me. So that is one thing which. Thank you so much.
Teachers always have to be very harsh sometimes. This is how that makes us a good student. So, two important points were discussed. One is the oil from chili seeds, and second one is that starch and pectin from wasted apples. So we can think of building an entrepreneurship into it in the near future, provided we have a good quantity of raw material available. So these two sectors have a very good potential to be started as startups. Thank you so much and congratulations for doing such a good job. Wonderful work. Now this is a small token of, I can use the term love from me, from SKUAST, from me to Rizal sir.